Okay, here's what you need to know about DME arcs. When you're doing a DME arc, you're going to be arcing, in this case, from this radial over to this radial right here, and then we're going to be flying inbound. Just in this example, that's what we're going to be doing. Here's the thing, okay? We're not actually going to be flying perfectly along this arc like this. In reality, what we're going to be doing is flying a bunch of straight lines, and those straight lines are going to be inside of the arc. So that straight line might look like this. We get to this point right here, and we go like this. Fly a straight line to right here. And then from there, we fly a straight line to here. And then from there, we fly a straight line to here. Now you're wondering, okay, well, why am I flying these straight lines? And how do I know when I'm going to get to this point on the line? And all these different things. You're wondering, how do I do this? I'll tell you right now, there's a formula you can use to get you exactly from right here to this exact point right here, presuming no wind. Okay, if there's wind, which is always going to be wind, it's going to be a little bit different. But as far as technically concerned, this is what we're doing. Okay, so the amount that you turn right here in order to arrive at this point right here is this. Okay, heading equals radial, which is what you're on. So in this case, the radial is right here. Heading equals radial plus or minus 90 degrees, which in this case, it will be minus 90 degrees. So 90 would be right here, right? This would be a 90-degree angle. So plus or minus 90 degrees. And then plus or minus 1/2 of your twist. Well, what is twist, you might ask? So let's say this. Let's say that we're going from this radial here. We'll call this the 90 radial. And we're going to be going to this radial here. And let's call that the 50 radial. From 90 to 50, that's a 40-degree angle. See? So 40 is your twist. That is your twist. You're twisting to 40, right? So the heading that I fly right here, in order to fly a straight line to right here at the 40-degree radial, would be my current radial, which is 90, plus or minus, which in this case would be minus 90. 90 minus 90 is, of course, 0, so north, so 360, plus or minus 1/2 of the difference in the twist. So in this case, the twist difference is 40. So from 90 to equals a 40-degree change. So 1/2 of that is 20. So the twist is 40. So 40 divided by 2, of course, is 20. And in this case, we were going to the left, so we will subtract that. So minus 20. So in this case, 360 minus 20 is 340. So when I get right here, if I want to fly a straight line from right here to this 50-degree radial, I would have to fly a heading of 340. That's what I've been saying earlier, right? So when it all comes down to it, the heading that you fly right here is your current radial plus or minus 90 degrees, and then plus or minus 1/2 of your next radial's difference, 1/2 of the twist. So let's break this down again here. I'm going to go make a new marking here. Let's say that we're doing the same exact setup. We're going to arc along this arc here, and we have joined it. So let's say we wanted to go from the 90 radial here. We wanted to twist to the 80 radial, which is going to be, say, right here, the 80 radial. So in order for me to fly a straight line from right here to right here, I got to figure out that heading. Now, of course, this is an imperfect example because I'm just drawing on my iPad, but just bear with me, all right? So what I would do is I would say this: heading equals radial plus or minus 90 plus or minus 1/2 of the twist. So by that being said, the radial is 90 plus or minus 90, in this case minus 90, is going to be 0, so north, 360, plus or minus 1/2 of the twist, in this case, 1/2 of the difference between here and here. This is a 10-degree, right? 10-degree difference. So 1/2 of 10, so times, 0.5, that's half, is 5 degrees. So in this case, 360 minus 5 is d5. So for me to fly my airplane from right here to right here would need to be a 3 heading. Now, let's say I arrive at this point right here and I'm on a heading of 3 and I'm on the 080 radial. And let's say I want to fly now to the 070 radial. So I do the same math. In this case, from 080 to 070, That's going to be a 10-degree difference. See, difference of 10. I should say this actually. That's going to be a 10-degree difference according to the angle here. So that was a 10-degree difference here, and now we got a 10-degree difference right here. Okay, so 10-degree difference. So heading equals radial. So in this case, the radial is 80. So 80 minus 90 is 350 because we're doing this off of a compass. And then 350 minus half of 10, right, which is 5, is 3. So now I would need to fly from right here, a 345 heading, to get to right here. So 345. So that being said, that is a 10-degree difference between here and here. So if I want to fly from 070 to now the 060 radial, same thing, 070 minus 90 is 340. And of course that minus half of the difference, which is 5, is 335. That's what I would fly right there. So I'll go from here to here on a 5 heading, just like that. Now, you'll notice we are currently turning in 10-degree increments. We're turning 10, right? But we're also twisting 10. And you're like, well, hold on a second, Toby. What are you talking about? Like, why are we doing that? You said not to do that. No, what I said is that your first turn will not be 10. Once you get in the system, you'll be 10, turn 10, twist 10. But to get into the system, the first one is 5. Because look right here. From here to here was not a 10-degree increment. Because see, 90 degrees from 90 is north. So it'd be, north equals 0, equals 360. See? But we didn't do that. We flew 5 degrees less than that. Because 10 degrees here, see, is a 5-degree change, right? So I flew 5 degrees less. But then by the time I flew from there to here, I was on that 5 degrees less heading, which is fine. And then I used the math again, which is the radial which I'm on, which is 80 plus minus 90, right, is 340. And then minus half of 10, which is 5, puts me at 345, which is exactly what I flew. It's the same exact math as the initial turn. However, the difference in heading is now 10 degrees instead of 5 degrees. And that's because the difference in heading increases because the direction changes. See, we're now flying along those straight lines. So we started from 360. Minus 5, right? It was 355. Cool. So the first one was 5. I'll draw it down here. So 360, minus 5, is 355. The next one, and the next one here, say from, here to here, this big spot there, is 345, simply because that's what the math comes out to. So it's 10-degree increments after the first 5. So if you do what I've been saying before, doing the turn 100 rule, which is also the same exact thing as turn 90 plus or minus 10, same exact thing, right? So if we turn 10 right here instead, we go 10 degrees, well, that's going to mark out these down here and make them 20. So we turn 10, twist 20, and then twist 20, twist 20, twist 20. So that's the whole point. So the easiest possible way to do this is to figure out what's my radial, right? Radial plus or minus 90, then plus or minus whichever twist you want, half of the twist, plus or minus half the twist. But guess what? If you don't care about the twist, then just do radial plus or minus 90 plus or minus 10. If that equals your heading, then what will happen is this. Increments will be 20 degrees-ish, technically a little bit more than that because this is 80 degrees. So it'd be a little bit more, it'd be like 20, 20, 20, then like, 10 here at the end. It'll be 20-degree increments starting from your first heading 10 degrees off. So 90 would be here, but you're going to fly from here to here, which is 10 degrees off. And then when you get from here to here, that will be a 20-degree heading change simply by nature that you adjusted 20 degrees from this radial. This radial was 90. Well, this radial is 70. So because of that, whatever you ended up flying to get from here to here is going to be 20 degrees less because your heading equals your radial. See, that's the thing. It equals your radial plus or minus 90 plus or minus 1/2 the twist. So all I'm saying is this is how it works. This is why, okay? This is like why it works. This is how it works, right? But all you need to know is take the radial plus or minus 90 plus or minus 10 degrees, knowing that it will cross 20 degrees of radials at arc intercept. And that is what you need to know.